All right, so in this one, we're going to be predicting the products from chemical reactions. And so we're just going to look at what we have and try to figure out um, what we're going to end up with. So when we start here, this is a compound, right? And this is a single element. And so whenever you see this, for the most part, what you're going to end up having is called a single displacement reaction, okay? So you have a single displacement reaction. And one of the reasons that this would be considered a single displacement is because one of these elements is going to displace the other one. Now, we know that this is copper 2 oxide because oxygen has oxidation of -2, and because there's some subscripts, that means that this copper was +2. And so with the copper and the oxygen, so we're going to end up replacing the copper with the carbon. And so carbon's going to be +4, because remember, cations replace cations and anions replace anions. So that's going to leave the copper by itself. So when I have my products, that means I have copper plus, and again, swap and drop. I'm going to end up with CO2. All right, CO2. Because when you swap and drop this 4, the 4 goes with the oxygen, the 2 goes with the copper, but then you reduce it to the lowest common, whatever it is, because I'm the math. But anyway, it becomes to be carbon dioxide. All right, so now the next one, notice that I have an element and an element. So this is going to result in what we call a synthesis or a combination reaction, where these two are going to actually come together. And so phosphorus and chlorine are both nonmetals. And so this is going to form, what is this one? It's PCl4. Is it 3? It's 3. PCl3. Yeah. PCl3. That goes back to phosphorus having 5 valence electrons and chlorine each having 7 valence electrons. And so chlorine needs 1 to complete its octet. Phosphorus needs those 3. So the 3 chlorines combined with the phosphorus goes back to those Lewis structures. So you're going to have PCl3 here. All right, now the next one we should be able to identify as an acid-base neutralization, which is a special type of double displacement. How do I know it's acid-base? Well, the first element in this compound is hydrogen, so that lets me know it's acidic. And I see the hydroxide here, which let me know it's a base. And so when that hydrogen comes with that hydroxide, it is going to produce water. And this is why it's called an acid-base neutralization. So I'm going to get a water and I'm going to get an ionic salt. The ionic salt in this case is going to be lithium carbonate. Lithium is in group 1, so it has an oxidation of +1. Carbonate is CO3, 2 negative. So I'm going to have Li2, CO3. Now these equations are not balanced. We could go back and balance them, but we've already done a video on balancing. In fact, you should pause them and see if you can balance this video, balance these equations. All right, now the next one we should recognize it as a combustion. Notice how I have an organic compound and I have oxygen. And so whenever you have a combustion, your reactants your products are automatically going to be carbon dioxide and water. I know that. So now, that's it. If you're balancing, you balance the carbons first, the hydrogen second, and the oxygens last. But when you have a combustion reaction, which is an organic compound, this is a hydrocarbon, that's an oxygen, your products are carbon dioxide and water. No harm, no foul, no guesswork involved. Last type of, these are the basic ones. Again, if you have any other questions, please let me know. Just doing the basic types of reactions here. All right, this one, notice that I have a compound and a different compound. So I have iron 3 chloride and I have sodium hydroxide. This is not an acid base because iron 3 chloride is not an acid. So this is just a double displacement or double replacement reaction. I know this is iron 3 chloride because of this 3, which tells me that iron has a charge of +3. We know that chlorine and halogen has -1. Sodium is in group 1, so it has a charge of +1, and the hydroxide polyatomic ion is -1. And so I'm going to swap my cation for cation, and so that means I'm going to put this iron with this hydroxide, and so I'm going to end with FeOH3, and I'm going to put this sodium with this chlorine, NaCl. So I have iron 3 hydroxide and sodium chloride. All right, so how do I know what each one of these are? Let's run back through it really quick. I identified this as being a compound and an element, so typically I'm going to have a different compound element combination as my product, so that's a single replacement or single displacement. Here I have 2 elements that came together to make one compound, that is a synthesis or combination. Here I had 2 compounds, but one of my compounds was an acid and the other one was a base. So this is a special type of double displacement called an acid-base neutralization. In an acid-base neutralization, I'm always going to have water and an ionic salt as my other compound. Here I have an organic compound. This is a hydrocarbon. Remember, organic compounds contain carbon and hydrogen, or carbon, hydrogen, and oxygen. And in this reacting with oxygen, and in an combustion reaction, the products are carbon dioxide and water. And here I have 2 compounds, and so one of them is a base, but the other one is not an acid, so it's just going to be a simple double displacement reaction. And in this double displacement reaction, I'm going to end up with the swapping of the same type of ions, either the cations or anions, doesn't matter. You swap cat for cat, and for and, but you cannot do a cat and an and. All right, cool beans.